Who defined thermodynamics entropy? Clausius or Boltzmann? Have you ever wondered about the origins of the term entropy in thermodynamics? It's a fascinating topic that connects to brilliant minds, Rudolf Clausius and Ludwig Boltzmann. Let's break it down to see who truly defined this important concept. Rudolf Clausius was the first to define and name entropy in the mid-19th century. He introduced it as a thermodynamic property that relates to heat transfer and temperature. Clausius formulated entropy mathematically, expressing it as the integral of heat divided by temperature. This means that entropy is a measure of how energy is distributed in a system. He derived the term entropy from a Greek word that means transformation or change. Clausius established a key connection between entropy and the second law of thermodynamics. This law states that in an isolated system, entropy can only increase or stay the same. It never decreases. His work primarily focused on macroscopic processes, especially in heat engines and reversible processes. Later on, Ludwig Boltzmann took the concept of entropy to another level. He provided a microscopic interpretation by linking entropy to the number of possible arrangements of atoms and molecules in a system. Boltzmann introduced statistical mechanics, showing that entropy measures the degree of disorder in a system. His famous formula expresses entropy as proportional to the logarithm of the number of microscopic states. This connection between the microscopic world and the thermodynamic concept defined by Clausius is essential for understanding how entropy relates to spontaneity. The more ways particles can be arranged, the higher the entropy and the more spontaneous a process can become. In summary, Rudolf Clausius defined and named entropy as a thermodynamic quantity related to heat and temperature. He laid the groundwork for understanding entropy in the context of the Second Law of Thermodynamics. Ludwig Boltzmann later expanded this idea, explaining entropy statistically as a measure of microscopic disorder and the number of possible configurations of a system. Both perspectives are important for grasping how entropy plays a role in natural processes and spontaneity. Understanding these contributions helps us appreciate the evolution of scientific thought surrounding this fascinating topic.